All right, this is a video on how to determine if a number in a set is an outlier. So if you look at the small set of numbers that I have for you here, 2, 10, 11, 12, 13, 13, 13, 14, 15, 16, and 18, the first thing that you would need to do is come up with a 5-number summary. Okay, so the Q2 is the middle number, 13. The median of the lower set is 11. The median of the upper set is 15. The max is 2. The min is 2. The max is 18. So that would be step 1. Now, the reason we need all of that is because we're going to really look at Q3 and Q1. And what we're going to do is we're going to subtract Q3 and Q1, and we're going to get 4. This number is called the interquartile range, also known as the IQR. It is the distance between the third and first quartiles. Now, if we had a box plot, which actually I'm going to do because it's a good visual. I think I have enough room to go and do them perfectly. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, here's 10, 11, 12, 13, 14, 15, 16, 17, 18. I can get all of my key numbers right there, no decimals, no rounding. So here's my min and my max, my median, Q1, Q3. There's my box. And some people call this a box and whisker plot, and they call the whiskers the lines that come off of there. So there's our box plot, and our interquartile range is a number that represents the distance covered by the box. So the distance covered by the box is exactly 1, 2, 3, 4. And that's our interquartile range. Now, in order to determine if a value is an outlier, you kind of get the idea that 2 might be. Right? 2 is way out of place in that data set. There are 2 values that we're going to use to determine whether or not a value is an outlier. And one is 1.5 and the other is 3.0. We're going to take 1.5 times the interquartile range, and it gives us 6. We're also going to do 3 times the interquartile range, which is 12. Now, these are the distances to determine the cutoff for an outlier. And what we're going to do is we're going to start at each of the quartiles, and we're going to go outward either 6 or 12 units. So if I went 6 this way, that would put me at 5. I think I just went too far. 1, 2, 3, 4, 5 is here, and that would be my first cutoff because that's a distance of 6. Okay, 11 down to 5. That's a distance of 6. And on the other direction, I think I can still fit the upper outlier. So 1, oh no, I really can't. Yes, I can. Just kidding. We're going from 15 out 6, which puts us at 21. So the upper cutoff for outliers is 21. So any number that is lower than 5 or greater than 21 would be considered a mild outlier using the 1.5 criterion. Now, as you can see, our maximum number is 18, so there are no outliers on this end of the data set. However, anything lower than 5 would be considered an outlier. So clearly this number 2 is an outlier. If I further wanted to check to see if there were any extreme outliers, I would use the 3.0 criterion. And clearly I don't have room to show that on the upper end, but on the lower end, if I went 12 units out, look at that, 12 units out would put me at -1. So that would be the other cutoff. The lowest cutoff would be at -1. Now clearly -1 is below -2, so -2 would not be an extreme outlier, but it does cause some concern. Another thing to kind of take a look at is if we were to, again, visually imagine this distance here, and then we're really doing 1.5 of those. So it's really, there's our visual, right? This is 1.5 times this distance. So that's what we're doing on either end of our box plot to see if a number is beyond that or not. So that's how you can determine if something is an outlier.